Hi, this is David Battino with Electronic Musician. For years, I've been making MIDI data detectors by mounting LEDs in Japanese monster toys. Lately, I've made some control voltage monsters too. These guys show gate and modulation signals. But there was one monster I'd been saving until I could work out a worthy circuit. Satan Beetle has 6 metallic nipples that just cried out to host a spinning sequence of LEDs. My circuit uses the popular 4017 sequencer chip. The 4017 takes an incoming pulse at pin 14 and distributes it sequentially to 10 other pins. Connect LEDs to those pins and they'll light up one after the other, then start again. To restart the sequence before the 10th output, disconnect pin 15, the reset pin, from ground, and connect it to the next pin in the series. For example, I wanted 6 lights, so I connected pin 15 to pin 5, which normally triggers the 7th LED. The pulse from pin 5 restarts the sequence. You can buy the 4017 chip in electronic hobby kits. Banggood.com sells a pack of 5 kits with LEDs for $5. Here's the kit I got. It includes a 555 timer chip to generate the clock pulse, but we'll use a MIDI keyboard instead. Most MIDI Out Jacks offer 5 volts at pin 4. Pin 5 is usually at 5 volts too, then drops to 0 when data goes out. So if you connect an LED between pins 4 and 5, it will flash when you play your keyboard. I used pin 4 of the MIDI jack to power the 4017, and pin 5 to trigger it. Here's my test circuit. My iPhone is running the Korg module app. It's also powering both the keyboard and the circuit over USB. Notice how each key triggers 2 LEDs, one for node on and one for node off. Aftertouch and continuous controllers send a burst of triggers. My other MIDI keyboards produced mixed results, so for a more consistent trigger source, I added the option to use a CV gate signal at pin 14. Now notice each key press advances the sequence by 1 step. And Aftertouch and other continuous controllers affect only the MIDI LED, not the sequence. Next, we'll rewire the circuit so it loops after LED number 6. Now we're ready to light up the monster. First, we'll grab a few more parts, including a MIDI jack, a mini phone jack, some header pins, and a small LED scavenged from a bouncing ball. The mini phone jack has an internal switch, which I'll wire to disconnect the MIDI trigger when I insert the CV gate plug. For stability, I glued magnets inside the monster's feet. Whoops. Next, I drilled 6 quarter-inch holes in his belly and added LED sockets. On the back, I made holes for the MIDI and CV jacks. Because space was tight, I used wire wrap instead of solder for most of the connections. First, I stripped the wire, then wrapped it around the legs of the LEDs. Next, I drilled out the beetle's horn and pushed the tiny LED in from behind. I tied a knot in the positive wire so I could tell which one it was. Now I've wired up the abdominal LEDs. Here I've snapped the LEDs into their sockets, and I've started making connections to the socket for the sequencer chip. Now the MIDI jack is wired up. I added a washer to the mini phone jack to keep the monster's body from cratering when I insert a CV cable. Pop on the head, and we're ready to play. First we'll trigger the lights with MIDI. Now I'll plug in the CV gate cable to change the trigger source. This looks especially cool when you drive it from an arpeggiator. And a funny thing, after finishing this project, I discovered that the original Satan beetle also has light-up nipples. Look out, Ultraman!